Section 2.4, to solve right triangles using the trig functions. Our first slide identifies significant digits for an angle. Here, it shows on the first part of the diagram the number of significant digits. And here, if I have 2, that would represent just a degree. For example, 35 degrees, 2 digits, just a degree. If I continue on and add more numbers to it, for example, 3, which would be 35.8 degrees, then that would represent to 10 minutes or nearest tenth of a degree. If we continue on, my units of measure get smaller and smaller to get a closer approximation to the value that I actually want on my degree. Let's take a look at our first example. Here they want us to solve a right triangle given an angle and a side. Our first definition we really want to look at on this slide is to solve a triangle means to find the measure of all of its sides and all of its angles. So this is a process that takes a couple of calculations. The first step is to draw a right triangle like the one I have here. Then I fill in the parts of the triangle. For all of our examples, we're going to let C be the right angle unless otherwise designated by the book. So here, A is an acute angle, B is an acute angle, and C is my right angle. And also I want you to understand that the measures of the sides are the lowercase letters opposite the angle given. So if this is capital B, the measure of this side opposite is lowercase b. Capital A, the angle, the opposite side's measure is a lowercase a. And for my right angle, a capital C, the hypotenuse would be represented as a lowercase c. Let's continue with the problem. I'm given that the measure of angle A is 42 degrees and 30 minutes. And I also know that this is a right triangle, so I have a right angle. Therefore, I know that angle A and angle B are complementary, so I can find angle B by taking 90 minus 42 degrees and 30 minutes, which gives me the measure of angle B to be 47 degrees and 30 minutes. Now I have all my angle measures, so I need to find my side measures. And from the problem, I know that angle A is 42 degrees and 30 minutes, but I converted this to a decimal degree by taking 30 divided by 60, which gives me 42.5 degrees. I also am given that the measure of side C is 18.4, which is my hypotenuse. Triangle related to angle A. For example, lowercase a is the opposite leg of angle A. C, of course, is already stated, the hypotenuse. And of the three values given, angle A, the opposite leg, and the hypotenuse, I know two of the three. Therefore, if I know two of the three values, I can find the third value, which is side A. So let's continue. If I identify the sine of A to be the opposite leg over hypotenuse, which is defined in previous sections, I can then substitute in for these values and solve for one of the missing pieces. So I know that angle A is 42.5 degrees. The opposite leg is unknown, which is side A. My hypotenuse is 18.4. I can then solve this problem by multiplying both sides by 18.4. So my solution for A should be 18.4 times the sine of 42.5 degrees. Now all I need to do is enter this equation into my calculator, 18.4 sine 42.5 degrees, and I get the final approximation to be 12.4 for the measure of side A. There are a couple of ways to get the measure for side B. One would be the Pythagorean theorem. Since I know A, I could use A squared plus B squared equals C squared, substitute in my known values, and solve for B. But since this is a trig class, I'd rather use trig functions. So to use trig functions, the first thing I need to do is to find an acute angle. Here, let's select angle A as we did previously. From this situation, I need to identify the parts of the triangle again. Again, A is my opposite leg, but I know that value. C is my hypotenuse, and I know that value. I need to find side B. And in relation to angle A, side B helps form that angle, so this would be my adjacent leg. Now, I need to use values that are known to solve for B. And this situation, I know angle A, I know C, which is the hypotenuse. I need to find my adjacent leg. And our trig function that deals with adjacent and hypotenuse is my cosine function. So cosine of angle A is equal to my adjacent leg over my hypotenuse. Now here, I have three values that are in my equation. I need to solve for adjacent leg, and knowing two of them, I can do that. Let's substitute in. So the cosine of A, which is 42.5 degrees, equals the adjacent leg, which is B, over the hypotenuse, which is 18.4. As before, I just multiply both sides by 18.4, giving me my equation B equals 18.4 cosine of 42.5 degrees. Now I just put that equation into my calculator, 18.4 cosine 42.5 degrees. And my solution is 13.5659. And when I round that to the nearest tenth, because my other sides are to the nearest tenth, that'll give me 13.6. So B is 13.6. And that solves for all the measures in this triangle. This slide is a solution to the previous problem. It just looks a little bit cleaner. You can see here that I have my right triangle. Angle B is complementary, so I can find that by subtracting from 90 angle A, which is 47 degrees 30 minutes. When they identified the sides of the triangle, again, sine of 42.5 degrees is the opposite leg over the hypotenuse, getting 12.43. They left an extra tenth of a degree, or an extra digit there, excuse me. That's okay. And on this one, again, cosine of A is my adjacent leg over the hypotenuse, and when they solve for that, the approximation is 13.57. We had 13.6. The next example for solving right triangles gives us two sides rather than a side and an angle. And we'll just run through this example and talk about it. So here what happens is we're given two sides of the triangle. We're actually given a leg and a hypotenuse. So they're going to find a third side by using the Pythagorean theorem. We already know that when I'm given a triangle ABC, the sides opposite the angles are designated lowercase. So here we already know that capital A, lowercase a, capital C, the hypotenuse is lowercase c. Opposite this acute angle is the side length of lowercase b. So here that's what they're solving for, and we know the Pythagorean theorem is a squared plus b squared equals c squared. And what they did is solve both sides by subtracting a squared on both sides, substituting in, performing all the operations, and getting the approximation to be 25.35. Now what they did is they needed to find the measure of an acute angle. So they selected angle A as the one they wanted to use first. So, and it doesn't matter. You could have selected B, but they selected A. Then what they did is identified the parts of the triangle based on the angle they selected. Here, side A, or 11.47, is the opposite leg to angle A. B helps form angle A, and it's also a leg, so this is the adjacent leg, And of course, the side opposite the right angle is the hypotenuse. And since they're solving for angle A, we know we need a function that is going to get us a value to get us a degree for angle A. They selected by knowing two values which are A and C, I can have an unknown of angle A. So for angle A, using my opposite leg and my hypotenuse, I can use the trig function of sine, which is my side opposite or opposite leg and hypotenuse. So the way we set up that equation is the sine of angle A is equal to the opposite leg, which is 11.47, over the hypotenuse, which is 27.82. Now, recall from previous sections, this is going to give me a trig value, or if I plug it into a calculator, a decimal, then I use the inverse function of sine to calculate for my degree of angle A. Now remember, when I'm finding a side, all I do is I enter the function as shown, like on the previous page, 18.4, and then the sine, and then the degree of the angle. In this situation, I'm finding an angle. Therefore, I have to use the inverse function, which means I press second, then the function that I'm using, which is sine, and I'm going to plug in my fraction as shown. I don't need a decimal. The calculator will take care of that as it uses its functions, which here, 11.47 divided by 27.82. Close parenthesis, and let's generate that answer. And as you can see, I get the approximation as the calculator, and as on the slide, 24.35 degrees. That would be when I round from 4 to 5. Once I have my degree for angle A, I know that I have two acute angles, and in a right triangle they are complementary. So I can just use that definition and take 90 minus 24.35 to get angle B, which is 65.65.